Good day, everyone. Today we're going to discuss and solve problems involving trigonometric ratios and right triangles. But before that, I am your Sir Stephen Escalante Hilyadula, a licensed professional teacher and a graduate of Bachelor of Secondary Education, major in Mathematics at West Visayas State University, a magna cum laude, and a proficiency awardee in Mathematics. I am currently taking my Master of Arts in Education with specialization in Mathematics. And also, I am a proud DOST scholar. First, we're going to discuss right triangle trigonometry. Although trigonometry is used to solve many problems, historically, it was first applied to problems involving right triangles. Given that that triangle is a right triangle, we know that first, one angle is 90 degrees. Next, the side opposite the right angle is the longest in the triangle. And also, the smallest side is opposite the smallest angle. Next, the remaining two angles are complementary. And so, if we know the other angle, we know all three angles in the triangle. And lastly, the sides are related by Pythagorean theorem. And so, if we know any two sides, we can find the third side of the triangle. And now, let's go to the relationship between sides and angles of a right triangle. In a right triangle, the hypotenuse is always the side opposite the right angle. The side opposite the angle is called the opposite side, while the side which forms one arm of the angle is called the adjacent side. In relation to angle A in the given diagram, the opposite side is side A and the adjacent side is side B. In relation to angle B in the given diagram, the opposite side is side B and the adjacent side is side A. If the two triangles have one pair of equal base angles, say angle B and angle Q, with a measure of x degrees, then their second base angles, say angle A and angle P, with a measure of 90 minus x degrees must also be equal. Therefore, the two triangles must be similar. Since the two triangles are similar, we know that the pairs of corresponding sides are in fixed ratio. AC over BC equals PR over QR. BC over AB equals QR over PQ. AC over AB equals PR over PQ. Taking these ratios one at a time, we have AC over AB equals PR over PQ, and that is equal to side opposite to x degrees over hypotenuse. Next, BC over AB equals QR over PQ, and that is equal to side adjacent to x degrees over hypotenuse. And lastly, AC over BC equals PR over QR, and that is equal to side opposite to x degrees over side adjacent to x degrees. Using the measurement of the complement of one of the angles measuring x degrees, we have BC over AB equals QR over PQ, and that is equal to side opposite to 90 minus x degrees over hypotenuse. Next, AC over AB equals PR over PQ, and that is equal to side adjacent to 90 minus x degrees over hypotenuse. Notice that AC over BC equals PR over QR gives us BC over AC equals QR over PR. And to continue, we have BC over AC equals QR over PR, and that is equal to side opposite to 90 minus x degrees over side adjacent to 90 minus x degrees. And we have the definitions of the trigonometric ratios in a right triangle. A trigonometric ratio is a ratio of the lengths of two sides of a right triangle relative to the acute angle theta. First, we have the sine theta in symbol that is sin theta, and that is equal to side opposite over hypotenuse. Next, we have the cosine theta in symbol that is cos theta, that is equal to side adjacent over hypotenuse. Next, we have the tangent theta in symbol that is tan theta, and that is equal to side opposite over side adjacent. SOHCAHTOA is the mnemonic device commonly used in remembering these basic ratios. So means sine equals opposite over hypotenuse. Ka means cosine equals adjacent over hypotenuse. TOA means tangent equals opposite over adjacent. We also have the reciprocal of those trigonometric ratios. First, we have the cosecant theta in symbol that is CSC theta, the inverse of sine theta. And that is equal to hypotenuse over side opposite. Next, we have the secant theta in symbol that is sec theta, and that is the inverse of cosine theta, and that is equal to hypotenuse over side adjacent. And lastly, we have cotangent theta in symbol that is cot theta, the inverse of tangent theta, and that is equal to side adjacent over side opposite. Now let's go to our problem number 1. Find the altitude of an isosceles triangle which has a base of length 28 centimeters and the base angles measuring 36 degrees. First, we're going to illustrate our problem. And for the solution, we need to find h. Since h is the side opposite the angle 36 degrees and we have the measure of the side adjacent to 36 degrees, then we will use the tangent ratio. As we all remember, tangent theta is equal to side opposite over side adjacent. Therefore, tangent 36 degrees is equal to h over 14. Multiplying 14 to both sides, we have h equals 14 times tangent 36 degrees, and h is approximately equal to 10.17 centimeters. For our problem number 2, a 6-foot ladder leans against a wall and reaches to a height of 5 feet. What angle does the ladder form with the wall? First, we're going to illustrate this problem. For the solution, since the hypotenuse and the side adjacent to theta are given, then we will use the cosine ratio. As we all know, cosine theta is equal to adjacent over hypotenuse. Therefore, cosine theta is equal to 5 over 6. To find theta, that is equal to arc cosine 5 over 6, and that is approximately equal to 34 degrees. Therefore, the ladder makes a 34-degree angle with the wall. Let's proceed to angles of elevation and depression. The angles of elevation and depression are measured relative to the observer. An imaginary line drawn from the eye of the observer to the object being observed is called the line of sight. The horizontal is the line of sight to an object directly in front of, neither above nor below, the eye of the observer. If the object being observed is above the horizontal, then the angle between the line of sight and the horizontal is called the angle of elevation. If the object being observed is below the horizontal, then the angle between the line of sight and the horizontal is called the angle of depression. And here we have our problem number 3. To determine the height of a tree, a student observes that it casts a 463-foot shadow when the angle of elevation of the sun from the top of the shadow is 31 degrees. Find the height of the tree. So first, we're going to illustrate this problem. For the solution, we know one angle and two sides of a triangle. The angle of elevation, the length of the shadow which is an adjacent side of the angle, and we want to determine the height of the tree, which is the opposite side of the triangle with respect to the angle. Thus, we use the tangent ratio. Here we have tangent 31 degrees is equal to h over 463. Multiplying both sides by 463, we have h equals 463 times tangent 31 degrees, and h is approximately equal to 278 feet. Therefore, we can conclude that the height of the tree is approximately equal to 278 feet. And now let's go to our problem number 4. An airplane is flying at an altitude of 5,225 feet, directly above a straight stretch of a highway along which a car and a bus are traveling towards each other. The vehicles are on opposite sides of the airplane. The car at an angle of depression of 42.7 degrees and the bus at an angle of depression of 54.2 degrees from the plane. How far apart are the vehicles to the nearest tenth of a mile? So we're going to illustrate this problem. We have x the distance of the car and y is the distance of the bus. Okay? For the solution, since we have the measure of the angle and its adjacent side, and we wish to find the opposite side, then we use the tangent ratio. First, for the car, we have tangent 42.7 degrees equals x over 5,225. Therefore, x is equal to 5,225 times tangent 42.7 degrees. For the bus, we have tangent 54.2 degrees equals y over 5,225. Therefore, y is equal to 5,225 times tangent 54.2 degrees. Finding the distance between the car and the bus, we're going to add x and y. So x plus y is equal to 5,225 times tangent 42.7 degrees plus 5,225 times tangent 54.2 degrees. And x plus y is approximately equal to 12,066 feet or 2.285 miles. Therefore, we can conclude that the vehicles are approximately 2.3 miles apart. Okay, so this ends our discussion for today. Thank you and God bless.